We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
News about mergers is usually found in the business section, but many objects in the universe, from black holes to clusters of galaxies, are also prone to mergers. And, like the corporate world, cosmic mergers are dictated by where the most assets lie. However, astronomical currency is not judged by money or stock reports, but by how much mass each object has. Dr. Nicola Brassington of the Harvard-Smithsonian Center for Astrophysics explains why so many objects in the universe are susceptible to such takeovers.
Every object in the universe that has a mass exerts a gravitational attraction. The more massive an object, the stronger its gravitational field. When two objects are close, both will exert a force on the other, and systems will interact. This interaction can range from the two objects simply passing each other, such as a comet on a slingshot trajectory by the Sun, to more extreme interactions, such as two clusters of galaxies colliding head-on, leading to the creation of one of the largest objects in the universe.
The Chandra X-ray Observatory, along with many other telescopes, has found evidence for merging in objects across the universe. Some of the most common, yet important mergers in the universe are those between galaxies. Dr. Brassington describes the state of mergers and acquisitions of galaxies, including our own.
Astronomers believe that nearly every galaxy that exists today has been formed or shaped by a close encounter or merger with another galaxy in its past. When two galaxies get caught in the other's gravitational field, they begin to spiral in towards each other, eventually forming a single, massive galaxy. This merger can take a few billion years, so it's impossible for astronomers to observe this process in a single system from start to finish. Instead, we look at snapshots of different merging galaxies at various stages of their evolution, with telescopes such as Chandra. We see these violent collisions not only change the structure of the galaxies, but they also produce new stars and create massive shockwaves that superheat the gas and dust within them.
Since there can be such a tremendous impact when galaxies merge, one question to ask is, what about the fate of our own home galaxy?
Our own galaxy, the Milky Way, is currently interacting with neighbouring dwarf galaxies, but these systems are too small to significantly change the properties of the Milky Way. Instead, the Milky Way will simply eat them up in an act of galactic cannibalism and, in the process, fuel the production of new stars in our galaxy. However, we think that our closest large neighbour, the Andromeda Galaxy, will collide and merge with the Milky Way in a couple of billion years. When this happens, it will have a huge impact on the Milky Way, completely changing the properties of the gas and stellar populations, and this merger with Andromeda will eventually lead to the creation of a much larger galaxy, completely unlike the one that we currently reside in.
While the collisions of galaxies themselves are fascinating and important to study, there are also other, even more violent and powerful mergers taking place. These occur when entire clusters of galaxies, which are some of the largest structures in the universe, ram into each other.
These massive systems, formed themselves through mergers of smaller groups of galaxies, can measure up to the order of a few millions of light years across, containing thousands of galaxies and trillions of stars. When two of these enormous objects smash into each other, the energy involved is phenomenal, surpassed only by the Big Bang. During these colossal mergers, shockwaves heat the gas between the galaxies to extreme temperatures of around 1,000,000 degrees Celsius. This makes the gas glow in X-ray light, which is viewed in detail by both Chandra and Europe's XMM Newton Observatory. By studying these extreme mergers, like the one in the so-called bullet cluster, we can learn how these systems evolve over time, and also gain information about the dark matter that they contain. Dark matter is a material that is responsible for holding these massive structures together, and makes up about 80% of matter in the universe. Dark matter is invisible to today's telescopes, however, it is still possible to detect this dark matter, but only through the gravity it exerts on other objects. Clusters and superclusters, the resulting product of cluster-cluster mergers, are great places to observe these effects, enabling the existence of dark matter to be tested and allowing its distribution to be mapped.
So remember, don't look for news of these cosmic mergers in the business section. While they may not affect the financial markets, mergers of cosmic objects are incredibly important. They play a key role in how objects throughout the universe and the universe itself have developed and continue to evolve. For more information, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.